When the Jeep Grand Cherokee was introduced in the 1993 model year, it created quite a stir. The introduction of the 2005 model will create even more excitement. There's still a long list of standard features and a choice of capable four-wheel drive systems. In addition, the 2005 Grand Cherokee is a more sophisticated and refined vehicle with available features like Smart Beam and electronic stability program. Welcome to this month's Mastertech 2005 Grand Cherokee and Minivan Stow and Go seats. Using a walk-around approach, we'll start off with a look at new features, systems, and components on the 2005 Grand Cherokee. We'll then give you an overview of the Minivan Stow and Go seats, including how they stow to create a flat load floor, and then finish up with underbody changes related to the seats. For 2005, the Jeep Grand Cherokee will be available in two trim levels, Laredo and Limited, and have two model designations, WK for Domestic Jefferson North Assembly Plant or JNAP built vehicles, and WH for Graz Austria built international vehicles. Under the hood, you'll find your choice of three engines, the 3.7 liter, 4.7 liter, and the 5.7 liter Hemi. The 3.7 liter and 5.7 liter have been added to the Grand Cherokee lineup and have seen use in other vehicles. You may remember these engines being covered in previous Mastertech programs. The addition of the 5.7 liter Hemi marks the first time that a Hemi has been used in a Jeep vehicle. The 5.7 liter Hemi uses the multiple displacement system, which deactivates 4 cylinders to improve fuel economy. To accomplish this, the system uses 8 standard and 8 MDS lifters, along with a modified camshaft to deactivate cylinders 1, 4, 6, and 7. The PCM operates solenoids that control oil pressure to each MDS lifter. Pressurized oil pushes a latching pin on each MDS lifter, which then becomes a lost motion link. Refer to the January Mastertech for additional details. Another engine-related change is the use of 5W20 motor oil in the 5.7 liter Hemi. Each of the engines we've just talked about have different cooling modules. The 3.7 liter uses an electric cooling fan, while the 4.7 liter has a hybrid system consisting of an electric and engine-driven fan. The 5.7 liter Hemi uses a hydraulic version driven by the power steering pump. Also under the hood, you'll find the integrated power module, which combines the power distribution center, or PDC, and the front control module, or FCM. The PDC and FCM provide electrical system protection in the form of fuses and electronic control over circuits. The IOD fuses are located within the power distribution center. Additional fuses and relays are located in the junction block under the instrument panel. The front control module controls a number of body electrical features based on hardwired inputs and bus inputs from other modules. The front control module also serves as the central gateway for the CAN bus system. In the area of transmissions, both the 4.7 liter and the 5.7 liter Hemi are coupled to the 545 RFE 5-speed automatic. If the vehicle is equipped with a 3.7 liter engine, the NAG-1 transmission is used, which Mastertech covered in a recent program. While the 545 RFE transmission control module is packaged with a PCM in a single module, the NAG-1 uses a separate transmission control module mounted inside the vehicle near the steering column on the bulkhead. Controlling gear selection on either transmission is a new shift lever Moving the shifter left and right with the shifter in the drive position allows the selection of the desired top gear. For example, if the driver shifts the transmission into third gear, the transmission will never shift above third gear, but can downshift to second or first gear depending on speed and load. Now that we've told you about the available engines and transmissions, let's take a look at the drivetrain components. The Grand Cherokee is available with two transfer cases, the single-speed NV140 and the two-speed NV245. In the area of axles, the Verilok is available on two-wheel drive models, while the conventional or electronic limited slip differential is available on models equipped with four-wheel drive. The Grand Cherokee uses various four-wheel drive systems, the first being Quadratrac 1. This system uses a single-speed open-center differential transfer case. Brake traction control, or BTC, is used to apply and release brakes on axles to distribute torque front to rear and side to side. Next is Quadratrac 2, which is a full-time four-wheel drive system using a two-speed transfer case with torque distribution to the front and rear axles. Quadratrac 2 also uses brake traction control to distribute torque. Last up is the Quadra Drive 2, which is the most advanced four-wheel drive system available in a Jeep. It uses the same two-speed transfer case for torque distribution to the front and rear axles. But unlike the Quadratrac 2, this system uses electronic limited slip differentials, or ELSD, to distribute torque from the left to the right side of the axles. The anti-lock brake module controls the brake traction control, or BTC. The final drive control module, or FDCM, controls the transfer case and electronic limited slip differentials. Operation of the four-wheel drive systems, the anti-lock brake systems, and the electronic stability program are closely related and rely upon shared inputs. For example, the Quadratrac 2 inputs include four-wheel speed sensors and lateral accelerometer from the anti-lock brake module, along with information from the next generation controller, or NGC, and NAG1 transmission control module, if equipped. The Quadra-Drive 2 inputs include all electronic stability program inputs consisting of wheel speed sensors, lateral accelerometers, yaw sensor, and the steering angle sensor mounted to the steering column module, as well as NGC inputs. Now that we've covered the engine and transmission lineup, let's move on to chassis items. All 2005 Grand Cherokees use the Mark 25E ABS system. You may want to note that ABS is now standard on two-wheel drive models. ABS with brake traction control is used on Quadratrac 1 and 2 systems and is commonly referred to as the brake traction control system, or BTCS. The electronic stability program is now available on 2005 Grand Cherokees. ESP is standard on Grand Cherokees equipped with a 5.7-liter Hemi and available on 3.7-liter and 4.7-liter four-wheel drive models. With Grand Cherokee's ESP, electronic brake system components provide BTCS capabilities, plus maintain directional stability. To determine whether the vehicle is responding properly to driver steering inputs, the ESP system uses a steering angle sensor mounted in the steering column module to sense the intended course of the vehicle. To sense the actual course, the system uses a sensor cluster consisting of a yaw sensor to detect rotation about the vehicle's center line and a lateral accelerometer to detect sideways motion relative to the center line. The sensor cluster is located under the center console. Under the Grand Cherokee, you'll find a short and long arm front suspension along with a 5-link solid axle rear suspension. If the rear subframe ever needs to be removed from the vehicle, remember to scribe the bolt locations, since the track bar mount locations and alignment are crucial. All 2005 Grand Cherokee models use a new type of hydraulic system, power steering fluid, with part number 05142893AA. Do not intermix or use any other type of power steering fluid in this system. One of the standard features on the Grand Cherokee is the tire pressure monitoring system. On the Grand Cherokee Limited, you'll find a premium system which uses 3 transponders along with sensors mounted on each rim. The premium system displays actual pressure for each tire in the EVIC along with a warning message for low pressure. One of the advantages with the premium system is that a relearn process is no longer necessary after a tire rotation. This is because in the premium system, the wireless control module uses 2 transponders in the front wheel wells and 1 in the rear to establish the location of the tire pressure sensors. Speaking of tires, the spare is now located under the vehicle in the rear. Now that we've shown you what's new with chassis components, let's move on to body exterior features, starting with the new Smart Beam headlamps. During nighttime driving, the Smart Beam system automatically turns on the high beams if it's dark enough and no other traffic is present. When Smart Beam detects an approaching vehicle's headlamps or a preceding vehicle's tail lamps, the system turns off the high beams. The system is designed to detect and, when possible, ignore ambient light coming from various sources. Some of the Smart Beam components are contained within or attached to the rear view mirror. These include the system camera, forward-facing light sensor, and the microprocessor. Along with having the stalk controls on the proper setting, the customer programmable preferences, accessible through the EVIC, must be configured to allow Smart Beam operation. High beams can still be manually controlled instantaneously by pulling the control stalk to activate the dimmer switch. The dial on the stalk control must be in the auto or A position for the system to operate. The system then operates automatically when auto headlamps are selected. The system will activate the high beams at speeds in excess of 20 miles per hour or more. If the high beams are on while decelerating, the system turns them off at about 15 miles per hour. Depending on driving conditions, the high beams may be faded on and off or switched instantaneously. The high beam indicator comes on when the high beams begin to ramp up and stays on until the high beams have completely faded back to low beams. To eliminate unwanted changes in system operation, Smart Beam can discriminate different light sources, such as oncoming headlamps, preceding tail lamps, road signs, street lamps, and ambient light. Whenever the windshield is removed or replaced, the Smart Beam camera should be properly aimed. Refer to the latest service information for details. Attaching the mirror button in the wrong location or improperly aiming the Smart Beam camera may severely affect system performance. Refer to the latest service information for complete details. When the rain sensor requires service, the mirror must be removed. Look for the Smart Beam system to be covered in greater detail in the July Tech News, including a list of frequently asked questions, or FAQs, which will help address customer concerns. The Grand Cherokee is equipped with the Express Open and Closed sunroof, which is calibrated similar to the Chrysler 300 and Dodge Magnum models. Refer to the January Mastertech or latest service information for the proper procedure. Another feature of the Grand Cherokee is Park Assist. The Park Assist module is located under the rear seat, and the Park Assist sensors are integrated into the rear bumper. When the system detects an obstacle, a visual display located in the rear headliner and warning tones alert the driver. You can disable the system with a switch located on the instrument panel. That wraps up the body exterior features. Now let's take a look at the interior and electrical system. The Grand Cherokee's electrical architecture uses a CAN bus communication system. In addition to CAN B, CAN C, and CAN C diagnostic buses, there's also a dedicated CAN bus and LIN bus, or local interface network. For a detailed look at Grand Cherokee's electrical architecture, refer to the chart in this month's reference book. Another notable component of the electrical system is the cab compartment node, or CCN, which is commonly referred to as the instrument cluster. The CCN provides control over and coordination of many body electrical features. The Electronic Vehicle Information Center, now located in the instrument cluster, provides information such as tire pressure to the driver. The EVIC is also used for customer programmable features such as automatic door locks and smart beam operation. The HVAC system used in the Grand Cherokee is similar to the system in the Durango. The automatic temperature control system communicates over the bus and will use the star scan for diagnostics. The manual temperature control version is not on the bus and uses the AC heater control for diagnostics. The evaporator temperature sensor is located at the left side of the HVAC module. It's now downstream of the evaporator for improved serviceability. In the area of communication and entertainment, a navigation system built into the radio is available to help guide customers to their destination. To help keep the kids busy on those long trips, a DVD entertainment system is built into the rear of the floor console. To add to the enjoyment of the DVD system, the screen now has a larger display area. For commercial-free radio broadcasts, the Sirius satellite radio offers a wide variety of choices. Well, that ends our look at the 2005 Grand Cherokee. Next, we'll take a look at the new stow-and-go seats available in the minivans. While minivans have a large cargo carrying capacity, it's sometimes time-consuming and tedious removing the seats to create a flat load floor. Daimler Chrysler has come up with a solution to that problem with stow-and-go seats. Not only is there no need to remove the seats from the vehicle to create a flat load floor, the entire process is accomplished easily and in under 1 minute. Let's take a look at how it works. To stow the third row seats, pull strap 1 to fold the seat back down. Then pull strap 2 until you hear a click to let you know that the front legs have released. And tumble the seat rearward into the storage bin by pulling on strap 3. To stow the second row seats, start by moving the front seats fully forward. Next, open the seat bin storage cover. Then, lift the adjuster handle and slide the seat forward, aligning the arrows on the seat and seat base. Then, pull up on the recliner handle and fold the seat back down. Pull the release strap at the rear of the seat and tumble the seat into the storage bin. Close the storage bin door to complete the process. As you've just seen, the entire process is extremely easy and can be accomplished in as little as 22 seconds. There's one last feature we haven't shown you yet, and that's how to change the third row seats into stadium mode for those who enjoy sporting events or picnics. To change the third row seats to stadium mode, first pull strap 2 to disengage the front legs. Next, pull strap 3 toward you to flip the seat over to the rear of the vehicle, completing the process. If the second or third row seats need to be removed from the vehicle for service, you'll need to use special tool number 9313. Refer to the latest service information for correct usage. Due to the addition of the stow-and-go seats, there have been some modifications to other parts of the vehicle you need to know about. Let's take a look. The spare tire has been relocated to the left side of the vehicle. The exhaust has been redesigned to flow around the storage bins of the stow-and-go seats. The floor pan has also been changed to allow for the storage bin design. You'll also notice that the fuel tank has been redesigned and relocated. Well, that's all the time we have for this program. Join us next month when we'll cover 2005 Dakota highlights and Chrysler 300 and Dodge Magnum all-wheel drive. Thanks for watching.